All right, so the same question applies here. We want to solve the exponential equation by expressing each side as a power of the same base and then equating exponents. All right, so 8 to the x power is equal to 16. We want to find x. So by looking at this, 8 squared, that wouldn't give us 16. That would give us 64 because you have 8 times 8. So we need to come up with a common base. What base do you think we would need to come up with or use? It's going to be 2. Can't be 4 because 4 to the second power wouldn't give us 8. 4 to the second power would give us 16, but it wouldn't give us 8. So we have to use base 2. So 2 to the what power would give us 8? 3. 2 times 2 is 4, times 2 gives us 8. So we're going to take the 3 times to the x that's already there in the equation, equals to 2 to the what power would give us 16? 4. Now that we have a common base, we're going to set the exponent equal to each other, and then we're going to take the x and we're going to divide, we're going to take the 3 and divide it to both sides, and we have x is equal to 4/3. Our next example, 2 raised to the 1 minus x is equal to 1 over 8. So we have a fraction. So here's the little catch here. So yes, we're going to use base 2. 1 over. Let's convert this 8 that's in the denominator. We know that this is going to be 2 cubed. But we want our base to be on the same level, the same line, and we have this in fraction form. So what we have to do to move this 2 to the third power on to make it on the same level? What do you think? Well, we would use the negative exponent property. What's going to take place, we're going to do the opposite because we want to move this 2/3 up to the numerator. As we move it up, you have to take the opposite of, when I say opposite, if this is positive, is when you move it up, it becomes negative. So then we have here on the left side, 2 to the 1 minus x is equal to 2 to the negative 3. So you may be asking, where is the 1? Well, we multiply 1 times 2 to the negative 3, it will still give us 2 to the negative 3. Now we have the same base for each side. We can drop it, and then our focus is going to be on the power. Okay, and solve for x. So we're going to subtract 1 to both sides. We have negative x is equal to negative 4. Then divide by negative 1. And we have x is equal to positive 4. So that will be our solution. Okay, some more examples. I like to give a lot of examples so you can have a lot of practice in different types of equations. All right, so 16 to the x is equal to 1 over the square root of 2. So first things first, let's convert this square root as a power. So 2 to the 1/2. So now that our base here in the denominator is 2, raised to the 1/2 power, we need to make the base on the left-hand side a 2. So 2 to the what power would give us 16. That will be 4, and we're going to times to the x that's already there. And remember, we want our bases to be on the same level, so we need to move this 2 to the 1/2 power up, and as we move it up to the numerator, the exponent becomes negative. So now we have a common base, which is 2. We can work on our focus on the exponent. So we have 4x is equal to negative 1/2. And how would we solve for x? So what we're going to do, I'm going to get rid of this 2 in the denominator. This is going back to basic solving equations. Let's times 2 to both sides. So on the left hand side we have 2 times 4x, which is 8x, equals 2. The right hand side, the 2's divide out, we have -1. And to solve for x, we're going to divide by 8. And we have x is equal to -1 over 8. All right. So next, 8x to the, 8 raised to the x plus 7 is equal to 32 raised to the x minus 3. We want to come up with a common base. We can't use 4. 4 raised to a power that would give us 32. You have 4 squared, which is 16. 4 cubed, which is 64. So that's not going to work. So each side, I can tell right now, we have to have a base of 2. So you have here 2. What 2 raised to what power would give us 8? That's going to be 3. 2 to the 3 times x plus 7. And you see I place parentheses around the x plus 7 because that's a binomial, equals to 2 raised to what power that would give us 32? That would be 5. Now we have a common base. Let's focus on the exponents and let's solve. Use the distributive property. We have 3x plus 21 equals to 5x minus 15. Let's subtract 3x to both sides. We have 21 is equal to 2x minus 15. Add 15 to both sides. We have 36 is equal to 2x. And then our last step, we're going to divide by 2 to each side. And we have x is equal to 18. There we go. Our last example. We have here e to the x plus 7 is equal to 1 over e. And that 1 over e, the power to this e that's in the denominator is 1. So I want to move this e to the first power up. We want it on the same level. So we have here e to the x plus 7 is equal to e to the -1 power. Now, just because we have a base e doesn't mean we don't use that rule. We have the same base. Our focus is going to be on the power or the exponent. So x plus 7 is equal to -1. Subtract 7 to both sides, and we have x is equal to -8. There we go.